Hi, this podcast runs alongside Handbook 5 and looks at paired two-sample parametric and non-parametric tests. These tests will be applied when either you've measured something from an individual twice and wish to compare the results. And this is called a paired test. Probably the best example is looking at pre and post trial data. For example, you might look at heart rate before and after exercise. This example here, we'll use two data sets. The first is heart rate, and the second is before and after test 2. Both of these are available via the Science and the Environment undergraduate program's Moodle page. I've downloaded both of those to my desktop to make it easier to download, to import into Archimander. So you should probably do the same, or somewhere that you can find easily or navigate to quickly. Okay, so first of all we need to do is import our data set. In this case, heart rate.csv. So we go to data, import data, and from text file, because it's a comma separated value file. Let's give it a name. Let's be consistent and call it heart rate, and make sure that we highlight commas here and click OK. I've saved mine on my desktop, so I'll navigate there, select heart rate, and click open. As with all data, as long as it's blue down here, it looks like the data is imported correctly, but let's view it anyway. So we've got three columns. First variable column is participant, so we looked at 20 individuals, and the second is before heart rate and after heart rate, with exercise having gone on in between. So we want to see if there's a significant difference between heart rate before and after exercise. So first thing we might like to do is get a summary of the data. Let's have a look at the values that we've got between before and after. So in order to do that, go to statistics, go to summaries, and then highlight numerical active data set. We're not so interested in participants here, and that's just the number given to each individual. These two outputs we are interested in, so we're looking at the mean here. So we've got a mean of 68, heart rate before exercise, and a heart rate of 95.8 after exercise. So there does seem to be quite a big difference in heart rate. What we'd like to know is that difference significant? Is there a significant difference between the before and after? So in order to do that, we need to apply a statistical test. As with other examples we used in other podcasts, we need to test any assumptions that are involved in any of the tests we're going to use. So the first of those is testing for normality. So if we go to statistics, summaries, down to Shapiro-Wilks test, we'll do the variable after first and then click OK. Alright, looking at our output here in the output screen, we've got our test statistic and our p-value, and we're looking to see if that's above or below 0.05. In this case it's above 0.05, so it's not significant. So there is no significant difference between our data and a normal distribution, which is good. So we need to do the same again for before. So we select that and click OK. And again, our p-value is above 0.05. So again, it's normally distributed or not significantly different from a normal distribution. So that's fine. So that first assumption of normality is fine. The second assumption is equal variance between our variables, between our before and after. So if we go to statistics and go down to variances, you'll notice that it's not highlighted. We can't select the Bartlett's test to test for equal variance. What we need to do is stack the data, so it's all our measured variables, all our measured data is in a single column. In order to do that, if you go to data, active data sets, and stack variables in an active data set. So you want to select before and after, and we'll just call this, we'll keep it as stack data. What are the name of the variables? So that's heart rate, and factor is treatment. So we'll just call it treatment, but we mean before and after. So we'll click OK, Alright, it looks like it's good. We now have 40 rows in this data set. It's blue up here, stacked data, and 2 columns. Have a quick look at it. You'll notice that the data has now been stacked. So all the measured variable is in one column, and the treatment, so before and after, is now in its separate column. So now we can, if we get rid of that, we should be able to do our Bartlett's test. So if we go to statistics, variances, and Bartlett's test, they're both highlighted here. So treatment is our grouping factor, and our response variable or measured variable is heart rate. And we click OK there. So looking at the Bartlett's test, we're interested in, well, we'd report all 3 values, but we're interested most in the p-value, and that is above 0.05. So it tells us that our data between the 2 groups, there is no significant difference in variance. So we can actually, based on both those assumptions, we can do a parametric test. So we can now test to see if there's a significant difference between the before and after with regards to heart rate. In order to do that, we need to go back to our original data set. So go back to heart rate here, click OK. So I've just clicked on this here. You can swap between any data sets you want there. So I'll keep on heart rate. And now you want to select statistics, click on means, and paired t-test. There's only 2 highlighted, and it's the paired t-test we're interested in. And then we want to select which variables we'd like to compare. So we want to compare before and after, and then click OK. Alright, so this is our output here. It's a paired t-test, so with all the t-tests you get a t-value. This is our test statistic value. You get a measure of degrees of freedom, which is your sample size minus 1. And we also get a p-value. This is in scientific notation, and usually is reported as less than 0.001. An example of how to report it, I can show you here. So if you look in the output, the script above, there's an example of how you might report the results here. So you could say a significant difference was shown between participants' heart rate before and after exercise. Then you report the t-value, the degrees of freedom, and the p-value. With such small numbers, you'd usually report it as just being less than 0.001. You may also mention that which mean was higher. So in this, our results showed a higher mean heart rate after exercise than before. So, and then you may report, in brackets, you might report the actual mean values before and after. So the results of our data show a significant difference in heart rate before and after. So it'd be interesting to then be able to visually display this, especially if you're going to put the data into the information into a report. So you may write out the difference highlighted here within a report, but you'd also want to graphically represent it. So if you go to graphs, go to box plot, and again, it only allows us to pick one or the other, so it makes it quite difficult for displaying this. So again, if we revert back to our stacked data set, click OK, and then go back to graphs, click on box plot, we've got our heart rate variable there, and we can plot by groups, and then click OK. You can add, as we've shown in other podcasts, you can add a title. It's already got labeled X and Y axis. Okay, so that's how you'd perform a paired parametric t-test. But there may be a situation where your data is not normally distributed or doesn't show equal variance. For that, we're going to move on to a second data set. So if we go back to data, go to import data and text file, we'll change this to before after test 2. We'll just call it before after 2. Click on commas and select OK. So we've got a second data set that's available, and that's before and after test 2. So click open. It's come up blue there, which is all good. Have a look at the data set again, and you notice it's a very similar layout. We got participants, we got the before, and we've got the after variable there. For the purpose of this example, we're going to assume that our data isn't normally distributed and doesn't have equal variance in there. Although if this was your own data, you would test both of those before proceeding. But in our case, we're going to assume that the data is not normally distributed. So we're going to apply a non-parametric paired test. And in our commander, this is called a paired Wilcoxon test. So if we close this down, we go to statistics, we go to non-parametric test, and our paired samples Wilcoxon test is highlighted here. We click on that. We want to select our first variable, which is before, and our second variable, which is after. Once you're happy with that, you can then click OK. Alright, so our results are down here. And in the output screen, and you can see again we've been given a test statistic, in which case is reported as 0, and our p-value, which is an incredibly small value again. So, but we're looking to see if this value is below 0.05. In this case it is. So again, there is a significant difference in heart rate before and after our treatments, which is exercise. You may want to then report this. I'm going to show you an example up in the script up here. So the first part, you may say significant difference was shown between the participant before and after, and then you report the test statistic, in which case is the p-value or Wilcoxon signed rank test value. You report the sample size, which in this case is 20, and the p-value. Again, because it's such a small number, you'd report it as less than 0.001. You'd also emphasize which treatment had the highest mean, median values. These are interchangeable. With non-parametric tests, you tend to use median, but you can report mean and median. So in order to get this, you go to statistics and you go your active data sets. And this gives us our mean and median values for our data. And you put those in there when you're describing your data in your results section. Once you've done that, you can then create a box plot and graphically represent your data as we did before. But both of those you would use if you've got paired data. Thank you.